Thank you. Thank you, Tim. Hello. My name is Anna Migas, and I work as a front-end developer and designer at Lunar Logic. This is a pretty special company. We're based in Krakow, Poland. We're a fully management company. Fun to work with. And also, as of the beginning of this year, I hold the title of Google Developer Expert in the area of web technologies. And you can find me on Twitter with my handle Shunshalicious. Good luck looking for that. So the title of my talk is Fast but Not Furious, Debugging User Interaction Performance Issues. For the past few years, I've had a chance to develop and maintain free open source libraries. They were all around animations, and when I was developing them, I tried really hard to make them as accessible and as performant as possible, to my knowledge. And during that time, I did a lot of reading on performance. Like really, I was reading everything that's popped up in my Twitter feed. And during this time, I've come to realize that there was one term emerging that was really obvious that everyone was talking about it, and this term was perceived performance. And while there is not one definition settled for perceived performance, it usually boils down to two things. First, meaningful paint, which is a metric that tells us how fast the user sees some meaningful content on the page. Of course, Paul will talk further about all the metrics. And time to interactive, which is a metric that tells us how much time will it take it for the user to be able to interact with the contents of the page. And then if you started to search further about perceived performance, you would probably get articles on things like how to optimize critical rendering paths, so how to take a part of the code that is responsible for what's up on the page, like above the fold, how to extract it and serve it to the user as fast as possible, how to use progress bars instead of spinners because they make user feel that something is loading faster, how to use placeholder content just as Facebook does. We have these gray areas where we know that any second something will pop up, so we anticipate the content there, or how some services start to upload the user media before the user even knows they want to upload something. They only just chosen this media in their device's library. So I read all these things and I started to wonder, like, is this really what we want to call perceived performance, all these techniques? Is this really what it should be? And to make it easier for you to comprehend why I am struggling here, I'll tell you a short story. So last time I had a chance to fulfill one of my biggest dreams in life and to reach the sacred valley of Machu Picchu after a few days of trekking. And unfortunately, on the first day, I felt really, really ill of altitude sickness, and it was obvious I'm not going to be able to walk on the second day. The second day was the hardest. We were about to reach the summit of the mountain, so I was given an alternative. I could either go back to the camp and after a few days just take a train to Machu Picchu, which is lame, or I could get on a horse and get on the horseback to the top of the mountain. So, of course, I've chosen the horseback rides as my option. And it turned out that I was at the top of the mountain way faster than the rest of the group. Actually, it was really pleasant ride. But what it turned out, at the top of the mountain, it wasn't really pleasant. It was snowy. I was already drenched because it was raining at the bottom and there was the snow at the top. It was windy and there was no way I could stay there for longer than 5 minutes. And they told me okay, so the rest of your group is going to be here in 40 minutes. So, while the experience of going up the mountain was really pleasant, what was on the mountain wasn't really pleasant at all. So I feel that this is something we have with perceived performance. We only care about how fast things will load, and then it is really actually perceived load performance rather than perceived performance, because we're caring more about faking this load metrics than anything else. So while perceived load performance is caring about going up the mountain and then leaving the user there for themselves, I believe we should care for real perceived performance, where we care also about the user once they reach our website and what happens with the user then. So I believe that perceived performance is not only about first meaningful paint or time to interactive, but also about having our website smooth at all times. And this is something we're going to talk about today. And this is probably something that is in this 97% of things that Steve just mentioned that are not that crucial, but I believe these are like really nice optimizations that we can have. So what we're going to talk about. We're going to talk about why sometimes interactions feel slow, about the browser rendering and frames, about the types of trigger changes in the UI, about how to test for interaction performance, and about some potentially dangerous UI patterns that you might already be having in your project and you don't know how to debug them. So why sometimes interactions feel slow? The reason here is junk. Junk can be in general described as lack of smoothness, the stuttering, something that is just not moving really smoothly. So once you see junk, you obviously see it everywhere, you'll never unsee it, and you're now exposed to junk in your life. I'm really sorry for that. So junk happens when the browser doesn't make it on time to render the frame it doesn't just have the same frame rate as our screen. And most screens on the customer market have 60 frames per second. So this is how fast we refresh our screen. So we have 1,000 milliseconds. We divide it by 60, and this gives us around 16 milliseconds to render each frame. So this is not much time. We already are struggling to make the browser make it on time. But there are some devices that go to the consumer markets that have 120 frames per second refresh rate. So this means that we have half the time we had before. These are namely the new iPads Pro and Razer gaming smartphones. So, well, we already had problem to make it on time with 60 frames per second. Our animations and interactions already are not that smooth. But with this frame rate, this might be a real challenge. I'm not saying that this is something that is going to happen, that all the devices are going to be running 120 frames per second. But as we saw with, for example, Retina screens, after some time, we started supporting higher pixel density screens, and like now we're doing this for almost every project. So maybe in some time we'll have to also be aware of the frame rate that we're going to have on our screen. And this is something that already is actually a standard in the gaming industry. They are already supporting the quicker screens, the screens with a higher frame rate. So web developers don't really know that yet, but game developers know how to work in between the frames, how to make things easier for the device to render things, how to work in between the frames. And this is something that we can actually try to have in our lives as well. So how can we help the browser to make it on time? So the thing we can do is to offload the main thread. So as you probably know, most of the things in our browser will run in the main thread. The main thread is for the UI. So if we have something really big, it will block the rest of the things because the things run one at a time. But there's also something called a background thread, which is supposed to be lifting some heavy tasks. So if you go to the website and it's not fully loaded yet, you see the contents are still loading, but you can scroll. It is because the scrolling is on the background thread. So we can take leverage of that. We can use web workers for heavy tasks. So if you have some like heavy JavaScript calculations or something really heavy in your JavaScript, you can use web workers and just take some luggage from your main thread and make it a bit leaner. But at the same time, it can also optimize the main thread. And this is something we're going to be focusing in this talk from now on. So the bottom line is, if we interact with the page, the browser needs to start serving frames, be it 60 or 120 frames per second. But what really frame consists of? So in frame, we have a sequence of steps. This is something you can also see in your performance panel, for example. And we here see the steps like JavaScript, recalculation of styles, layout, paint, compositing layers. So the thing you need to know is that these steps need to happen in the sequence. You can't have, for example, layout before JavaScript, because then you need to re-render the frame. So this these steps always need to be happening one after another. But this doesn't really tell us much, right? So let's go quickly through what is browser really doing during these steps, what is happening under the hood of each of the steps. Of course, we're going to take a bit simplified approach. So first, the change happens and an event is fired. So it doesn't necessarily have to be JavaScript. It can be any type of event, for example, scrolling, hovering over element that will change on hover, and things like that. After that, the styles needs to get recalculated accordingly to what just happened, to get your change visible for the user. After that, we have a layout step. At this point, the browser is trying to figure out where each element is going to be positioned and how much space it is going to take. And it's showing it as a collection of vector boxes. After that, everything is rasterized and it's painted to the layers. So we take our vector boxes and we change them to the pixels. So I said it's showing it, it's putting it onto the layers. So you can think of layers as layers in Photoshop, that if you have two things on the same layer, they're glued together and you rather don't move them around. But if you have one thing on one layer in Photoshop and another thing on another layer, you can move things around and they don't affect each other. And this is something we can actually leverage when we're, for example, thinking about animations or interactions. So we have our layers, but the thing is that the browser will, of course, it's all implementation feature. Browser will put everything on one layer by default. But there are some certain actions or certain properties that would make our browser move things to a new layer. So let's quickly look at this. So first, if we have 3D or perspective transforms, this will create a new layers. If we have 2D transforms or opacity, but they have to be animated so that they would be put on another layer. If we have element that is on top or a child of already existing compositing layer. If we use accelerated CSS filters in our website. In some special cases, if we have tags such as video or canvas, or if we use plugins like Silverlight or Flash, then the browser knows, okay, so probably there is going to be a video. This part of the page is going to be changing a lot. So maybe let's just put it to another layer because it will make it easier for the rest of the page to be rendered. And then we have one special property which lets us tell explicitly to the browser, I know this part of the page is going to be changing a lot. So I think it's a good idea to put it to another layer so that it wouldn't affect the rest of the page. And this is a CSS property called will change. Using will change is pretty straightforward. So we just need to say to our style sheet, will change, and then the property that is going to be changed. So in this case, we have a button, and we know that we want to change it a bit on a hover. So up front, we say like will change transform, and then we transform. The thing is, we need to do it up front, so it doesn't make sense to say will change already when we're hovering over the button, because at this point, the browser is already putting our element on another layer, so we need to like say it up front that this part of the page is going to be changed so that we would have this layer up front. And also another thing is that every layer consumes memory, so we should use them wisely. So if we have too many layers, probably we're not going to see it. We're using pretty good devices for the development, but if someone is using some feature phone, some older Android phone, too many layers can actually cause the browser to crash because each of them will take some part of the CPU. So you want to have some like balance in between how many layers you have and if you really, really need them. And then the last step we have in our pipeline is compositing. So compositing is basically taking our layers and putting them together into one image, one frame that is then shown to the user on the screen. Compositing is pretty special. It always happens when we have more than one layer. And also compositing takes advantage of the GPU. So we're taking a part of work from our CPU and putting it to the GPU. So this is really a great thing. And this is something that we can use then for our animations. But Those were all the steps that we can have in our pipeline, but it doesn't necessarily mean that we have to have all of them in each of the frames. And there are different types of trigger changes. And some of them are more performant, some of them are less performant. And like using some of them makes more sense than the others. So let's go through this type of trigger changes quickly. So first type of trigger change is a layout change, also called a reflow. In this case, all of the steps are going to happen. It happens when we change properties like margins, width, left, top, display, and everything that needs to change the geometry of the page. So to change like where elements will be positioned and how much space they're going to take. And in this case, we need to go through the layout step, then we need to repaint everything and go through compositing layers. So it's this really heavy type of change and it really should be avoided. Next type of change is a repaint. At this point, the browser knows exactly where everything is positioned and how much space it's taking. So we can skip the layout step completely. So it's a bit less heavy type of change. It would happen when we change properties such as background color, box shadow, color, background image, and things like that. So this is a bit less heavy type of change, but anyway, painting can be really a bottleneck in some of the pipelines. So we should also try to avoid it. And then last is the compositing change, which is the most performant type of change. It happens when we change properties such as transform and opacity, and this is the most performant type of change. As we said before, the compositing takes advantage of the GPU, so it is a type of change that is going to happen anyway if we have more than one layer. So this is really performant, and if you are going to remember one thing from this talk is if you're going to animate anything or make interaction out of anything, use only transforms and opacity if it's possible. But how to actually test if we have a problem? Like this reflows and repaints might not be that obvious at the face value. So actually, reflows can be quite obvious. If we go to the page and we see that one element is changing its size, but we're not really using transform scale on it, or this element is pushing other elements away, we can pretty much say probably we're experiencing a reflow there, and this is something that we should fix right away. But repaints are not that obvious. It's a bit harder to find out if we are experiencing them ever since we're using like pretty good devices for our development. So for example, here in this case, the repaint won't happen on the last star in the row because it's not overlapping the text when the heart is popping up. So this is something I was actually surprised to find out, and I find it out thanks to the DevTools. And the DevTools are something that's you want to use when you're testing for the interaction performance. So now we're going to go quickly through the best tools to do this kind of work. So first is the performance tab. It was already mentioned by Harry, and it's probably the first place where you should go. This green, long green thing is a frame, and it tells us how long the frame is. So as I said, it's good if our frame is around 16 milliseconds. If it's longer, you can just click on it, and it will tell you from the bottom up what takes the longest in each frame. So you can like go through it and see what should be taken care of. To have your recording, you just need to go to the performance tab, hit record, and then start interacting with the page. The shorter the video, the better, because it's then easier to debug, and you'll get a lot of data there. If you have only like these green bars, it means that everything is optimized. If you have something more, probably you're experiencing some problems here. And also there's a tab like that in Firefox if you want to test it there as well. Then there is a layers tab in Chrome. It's a bit hidden. You need to go to this three-dot menu with more tools and then enable that. It's amazing thing. It shows us all the layers that were created on our page, so we can see any excess layers that shouldn't be there. It shows us the list of them, and if you click on any of the layers, it will tell us the reason why it was created. So it is actually a really great tool. Also, you can just make this like 3D preview, which will tell us this, what the stacking context looks like. So it's like really useful for us to understand how our page looks like. Unfortunately, layers tab is a bit heavy. Like sometimes it would crash my browser. Sometimes I have a bit of problem with that. And then I go to the rendering tab, which is also in Chrome. It also has layers borders, so we can still see where our layers are created, but it also has really useful things like paint flashing, which will tell us which areas are getting repainted when we interact with the page. Or we can have like FPS meter that will show us if we're running 60 frames per second or some scrolling performance issues if we want to. So if we enable that and we start scrolling, for example, Facebook, these green areas are what is getting repainted with every time we scroll. So we can see like the scale of the problem that we have on our page at one glance. We also should test in Firefox because sometimes if you're scrolling, for example, a feed in Facebook, sometimes you would hover some things that you don't hover in Chrome. So you can see some other repaints than in Chrome. You need to go to the settings and toggle paint flashing if you want to test that. Last but not least, there is a performance monitor tab in Chrome, also hidden in the same place in more tools as a layers tab. And here we just go, start interacting with the page, and we'll see if there is a problem or not very quickly. So it shows us things like CPU usage, if we're experiencing any style recalls or reflows. So basically, when I was interacting with the page, that was pretty optimized. It was only a few % of CPU usage, no reflows at all, only a few recalcs. If I was interacting with some other page that was not optimized at all, it was like 70 to 90% of CPU usage, a lot of reflows and a lot of recalcs. So it's like very easy way to see if something is going on your page. But well, probably we would go crazy if our page is really, really big and we have a lot of things going on there. We don't want to test every single thing, every small thing, if it's not performant with all these tools. So, but there are some potentially dangerous UI patterns that if you have them in your page, you probably should test them. And these are like the first places to look for problems. So what are these UI patterns? Let's go through them. First thing is animations. If you have unoptimized animation on your page, probably most of the users will see it. It will be janky, it will be slow, it won't be really giving any enhancement to our page. So what can we do about it? First, don't overuse animations. If you only can skip the animation, just do it. If your animation is not guiding the user through the app, if it's not helping to understand what's going on in the application, if it's not giving the user information about the state of the app, and it's only like a graphical and it's just like a nice enhancement, you can skip it. You should also animate only transforms and opacity if it's possible because of this use of GPU on the compositing stage. Also, you should use requestAnimation frame. If you're going to animate things with JavaScript, it's a good thing to do. To use it, you just need to call it recursively from inside a function, and then, of course, for the first time, also use requestAnimation frame to invoke the function. But you need to remember that if you're using some libraries, some of them already have it built in. Also, you don't need it when you're using Web Animation API. And also, there is one thing. You should use requestAnimation frame, but if you want to support this 120 frames per second screens now, you probably shouldn't use requestAnimation frame. In this case, you should probably go to using CSS animations or Web Animation API. And it's because some browsers, especially I think it's mobile Safari, they have a cap of 60 frames per second for requestAnimation frame. So it doesn't really do what it says it does. It doesn't request animation frame every time the screen refreshes. It only requests it 60 times per second. It's done because of the they don't want to fry the battery of the devices, and something that was introduced some time ago. So they don't want to fail at backwards compatibility, so it's rather might not be changed for some of the browsers. So if you want to support the screens, rather go to the CSS animations or Web Animation API because they don't care about the refresh rate that much. Also, you shouldn't animate elements that are below other nodes, like some fixed elements or just other elements, because you might be experiencing some weird layout creation ad hoc that you don't want. And also, you shouldn't animate too many elements. So even if your animation is really optimized, you have like only transforms and opacity, but you try to optimize around 1,000 elements, it's not gonna be working really well. The browsers are not prepared for that. So if you want to like have a nice snow animation on your page for winter, you should rather not do it with 1,000 divs, but like use some clever technique to do that. Then there's parallax effect, which is my favorite. So I was actually looking up like performance parallax effect on the web for this presentation, and this one is what I found. Actually, it's not that bad. I've seen worse. So what you see here, like these green areas, these are repaints, and what we're experiencing here is a paint storm. So the page gets full repaint with every frame. So as you can imagine, it's not really performant because of this parallax effect. And parallax effect causes paint storms, and it's almost always bad. And if you really, really need to have it on your page, you shouldn't use scroll events, or you shouldn't use background position, because these are both techniques that will cause these paint storms. And if you really need to use it, you should use the technique with 3D transforms and perspective. And here's the link how to do that. But if you can, just tell your clients it's not a good idea. Fixed elements. So they've become a highly popular. Like you can see everywhere, there are like fixed headers. You can have some fixed intercom widget on your page. And the problem with them is that if we scroll, they get repainted with every frame, because the browser needs to create a new image, like with this fixed element and with what's behind it. Thankfully, you can fix that pretty easily with using a wheel change for your fixed elements. So wheel change are actually transform translate 3D, which doesn't move element anywhere, but it creates another layer. As I said, like 3D transforms will create another layer as well. So you can just have this fixed element and tell what will change. For example, will be transform. We'll have this another layer, so it won't be. It will be just independent of the rest of the page. So it's a pretty cool technique. Scrolling events. Well, you can probably say that this is not the best idea to hook some scrolling events to the whole page. So you shouldn't rather attach wheel or touch listeners to the whole document. If you really need them, you should rather go to attaching them to some smaller areas. And also, what you can do is to take advantage of passive event listeners, but you should use them with polyfill or feature detection. So as you can see here, we're having some event listener for scrolling, and then we pass this passive true flag to it. Why do that? What does it give us? So by default, if we're having some event listener for touch or wheel listeners, the browser is at all times anticipating that we might call prevent default. So like user is scrolling, our event is fired, and its browser is like, will it prevent default, will it prevent default, will it prevent default. So you can feel that it's like a bit an overhead for the browser. There's like one more thing that the browser needs to do all the time when our function is running. So if we pass this flag, what we say is like, browser, I will never call prevent default inside of this function. It can be safe. And browser will just not do that. So it's like one less thing for the browser to do when we're having this really heavy action. I mentioned before that scrolling was put to like background thread because it's so important. So you can imagine that just firing some functions all the time with scrolling might not be very performant sometimes. Hover effects. Usually they're harmless unless there are too many and they're like very easily triggered. So say we have a page and like person is scrolling and they just hit this big box that changes on the hover, and if our element is not extracted to another layer, it can just cause a reflow of the whole page. So this is something that might give this small lag, this small junk for the user, and like give a feeling that something is not really performing well there. So what we can do is that if we're like 100% sure that's, or maybe 95% sure that the user is going to go to this element and hover it, we might put it to another layer. Of course, with in mind that we shouldn't be putting too many elements on other layers because, well, we might fry their CPU. As I said, if there are too many happening too easily, if we trigger things like showing a tooltip and not using really a property that is not triggering layout or paint, it can be really a pain. So yeah, we should also remember to use for such interactions only opacity and transforms. And here is a link to a great page by Paul Lewis, which lists all the properties that we have, all CSS properties, and it tells us which type of trigger change will happen, like if it will be a reflow, if we're going to experience a paint, or if it's going to be only a compositing type of change. So it's a really, really great resource. Then there is appending elements. Like we're having it everywhere. Like our example of learning app is a to-do list where we are appending or removing elements. So what happens then? Here we are appending an after pseudo element, and basically the rest of the page to the the rest of the context of the page is getting repainted every time we do that. Thankfully, here it's not getting reflown, but it also can cause reflows in some cases. So what can we do about it? We should make sure that not that many elements are being affected by our change, by our appending or removing elements. We can try to separate the area, so we can take it out of the context using will change, put it to another layer. We could also use contain layout if the support was bigger. For now, it's really well, it's not something you should use in production yet, but once it's everywhere, I'm really looking forward to it, because contain layout tells us like, just take this element and nothing from inside of this element should affect things outside of it, and anything from the page should affect things inside of this element. So it's like really great property, but not there yet. And we should also consider not changing the size of the area, so like having a nice container with fixed size, overflow property, put to another layer with will change or contain layout, and then we can be safe that we're not causing any reflows for the rest of the page. Of course, in some small sites, when the things that can get repainted is like a few elements, it's not going to be a problem. But if we're having like a big new site, it can really be a bottleneck. Images. So images are not that much part of interactions, but there are so many things that can go wrong with images that I decided to put this part here. Also, Cornell is going to have a talk about it tomorrow, so I'm trying to not step on his toes here, but I'm going to cover a bit different things. So there are so many things that can go wrong, and I only picked 3. So I'll say something about how they can be downloaded in some unexpected ways, about potential content jumps on load, and about how lazy loading can be tricky sometimes. So let's start with being downloaded. So there is a great comprehensive research by Harry, who was speaking here earlier about when and why browsers would download the image. And it turns out that, in this case, semantics mean performance. So how the image is embedded, whether we use an image tag or we use background image, will influence the time of the download of the image and the time when it shows to the user. So you probably know that if we have image that is important for the user, if the user should see the image and it's crucial to understand the content, it should be with the image tag. If we have image that is only for decoration, it should be a background tag. It's a rule of thumb. So if we have images that are appended using the image tag, they'll start to get downloaded at the same time that CSS does. So if we have some page that is really content, like images, like the big part of the content, like Tumblr, Unsplash, or any page where images are like the main part, we should be using the image tag. And if we use the background image tag, the images will only start to get downloaded once they are discovered inside our style sheet. So this will offload, this will make them start download a bit later, but at the same time, the browser will have some more power to do some other heavy lifting that should be at the same time. Also, there's one thing that is discovered, that if we have image that should be only shown on mobile, and we don't want to show it for the desktop users, we should override the background property. So we should say like background none or background some different background. Otherwise, it will get downloaded even if it's not visible, even if it's not inside of the breakpoint that we're currently using. So this is something also to bear in mind. Then the content jumps. I believe all of us already experienced that. Like we go to the page, we start reading because we go there quickly to the text that we are looking for. We read it, and then some image at the top of the page will get downloaded, and it just pushes things away. We don't know where we finished. Thankfully, it's not happening in Chrome anymore. Since version 56, we have scroll anchoring enabled by default, so sometimes it causes some problems in some special cases, so you might want to turn it off. But anyway, it's a great thing that happened to us, to people who are using Chrome. Also, we can avoid it by using placeholders. So for example, we can use the intrinsic ratio technique, which will let us have a fluid size of the images. So what we do, we just take image height and image width, we divide it, and then we multiply it by 100%, and then we use it as our intrinsic ratio variable. We put it, we have some container inside the container, we have our image. The container will have a padding button with this intrinsic ratio, the height of 0, and overflow that is hidden, and inside the image will have a position absolute to the top left. And thanks to that, we have this container that will mark the space where the image is going to be happening, and we will not have this content jumps. We can style it, so this is a pretty useful technique. And then lazy loading. I know that lazy loading is considered as a performance technique because we're not making any additional downloads that we shouldn't be having. We're not downloading content that is not really useful for the user yet. But sometimes it can cause some problems, especially when we have really big amounts of elements that need to get lazy loaded, and they can cause a reflows for this whole part where they get appended. So actually, I found out about this only because I read some case study by Zalando in which they were saying how they actually removed lazy loading from their pages, because they would just have this someone searches for shoes and there are 120 items to show, and they had lazy loading there, and it was just causing reflows everywhere. So people would see a lot of junk, and scrolling was terrible. So they removed lazy loading, and what they used was low quality placeholders. So similar technique or any kind of placeholders really. So similar technique to what we were saying in content jobs, where you could basically just mark the space where the image is about to show, and just not cause reflows for the user. And they saw that it was a great increase in the performance. I really recommend reading this. That article is really interesting to see real life getting better in front of our eyes. So yeah. So this was the last technique I had when it comes to our UI patterns that can go bad and our interactions. So here's the list of the takeaways. So the junk happens when the browser refresh rate doesn't hit the refresh rate of our device's screen, and when the browser doesn't finish rendering the frame on time. We should try to offload and optimize the main thread. And we can use, for example, WebWorks for that, or any technique that I just mentioned. We should avoid content reflows and repaints, so we should only try to trigger changes that are happening on the compositing stage. So we should use opacity and transforms for our animations and interactions. We shouldn't overuse the layers, because they can crash someone's browser if they take too much CPU power from them. We should also try to test our website with performance layers and rendering tabs. And this is really important. We should always try to test before we make any of these optimizations, because optimizing upfront may actually make the performance worse. And we should try to really be responsible of using these potentially dangerous UI patterns. We should know how to do them well, how to avoid making the page bloated and hard to use for our user. So here's a list of the resources. I'll definitely upload the slides, link the slides in the tweet. And thank you. You can find me on Twitter as Shanshilicious again, and it's a pleasure.
Yeah, really nice work. I feel like there was no shortage of tips and tricks in that deck. I feel like people's notes probably expanded by a dozen pages. So no, that's great. That's great. So first off, can I just say 120 frames per second scares the hell out of me. That sounds frightening. We haven't even mastered the 60 frame per second thing. Have you had a chance to look at any of those devices on 120, and how big of an issue is it?
I haven't. I saw a video, I think it was on Chrome channel. They had some video, they were talking about how big the difference is, and they said that there was some animation that was developed for 60 frames per second. With the cap of 60 frames per second, then they would go to this 120 frames per second device, and instead of having a nice snow, it was just a snowstorm, because it was happening twice as fast, and it was awkward and weird. So.
And kind of piggyback, so you also mentioned several times the fact that certain lower power devices are going to experience this very differently. And then you mentioned requestAnimation frame as one of those things where if you're worried about that 120 frame per second thing, you don't want to be using that. Are there situations where we're going to find ourselves trying to hit this 120 frame per second that's potentially going to be a negative, have a negative fallout for those people on those mid or low end devices?
Well, it's hard to say. Probably if we use Web Animation API and we don't support it fully, we don't polyfill it, it might have some impact. But if we decide that we are able to come up with animation or interaction using CSS animations, I feel that it can actually make things better for these devices. CSS animations, really optimized. They work with the browser well. The browser knows when to run them. So I believe if we actually move from requestAnimation frame and some heavy JavaScript animation to the CSS animations, it can actually make it better. But of course, we can do everything bad if we develop it badly. So
this is true. How do you recommend testing it? You were mentioned, the situation across different devices. Do you recommend firing up different devices? Do you need a device bed for this? Do you use Chrome throttling? Is that good enough?
Yes, I use Chrome throttling. I really like Firefox DevTools for debugging animations. Also, the performance tab is just perfect for we record and we can see every screenshot of what's going on with our animation. Also, just recording it with throttling really helps. Throttling usually it's enough to see if we have a problem or not. Yeah.
Okay. And then have you found any good ways of monitoring this over time? So, say particularly for folks with the single page architecture, right, where a lot of it is this post-load interaction. This is a really important thing for them to keep tabs on. Do you have any tips or tricks for folks for, how do they sort of track and keep eyes on perceived performance issues so that they know they're not causing havoc or regressing?
Well, I don't have it figured out yet. To be honest, I'm experiencing problems with that as well in my project, and I'm really looking forward if someone has a really good tricks on that, monitoring for the future if something is happening. But usually, if the page doesn't really get performance at the beginning, it probably will not get better over time. So we should start with what we can do.
The present kind of a thing. Absolutely. Yeah. All right. Makes sense. All right. Well, thank you very much.
Thank you.
Thanks.